Yo yo. I was just doing some like offline work and found like a pretty sick fix to a bug that I had, and I just thought that I would quickly record and share what happened because I thought it was pretty fun and interesting. So, for context, we've been working on this meal tracker website, right? And we don't have to go into it too much, but part of the things that we've been trying to work on this website is try to do everything in WebAssembly instead of working in JavaScript because I hate working in JavaScript. So, we are going to when we load this page, we're going to make some network requests to the server. The server is going to come back with some JSON. If I can figure out how to show that, maybe. I don't know the Chrome dev tools very well. So network response, that's not very useful. Can I please show something? Here we go. Nice. So we're gonna ask for some JSON that's going to be fed back to us, and we have to generate a bunch of links based off of what's in here, right? So, in here, hello, UTF-8, sir? UTF-8? No, I can't. UTF-8, there we go. So in here, right, we're going to have ID1, Wonder Bread whole wheat bread, and down here, that's going to turn into a link that actually lives underneath the bread category, but it's going to, so that's a bad example, but maybe... Hello. Maybe here. ID3, name onion. Onion's going to show up in this link as a link to someone, right? And so we are processing all this up in WebAssembly land because I want to do it over there for no reason other than because I feel like it, right? And so that means that we have to do JSON parsing of this response in WebAssembly land, which is fine, right? That works. But it means that if we are trying to do a bunch of complex logic like JSON parsing and generation of stuff in Zigland, then, occasionally we might hit a bug, right? We might have an error show up, and we might want to diagnose that error. And it turns out that with the way things are right now, if I were to just go into ingredients Zig, and throw somewhere in here, just throw a if true return error, right? Build this guy really quick, and Control-Shift-R. We do see an unexpected token, right? He says, something went wrong, which, note, isn't the error that we returned. And trying to figure out where this originated from is actually not trivial. And it's because in normal Zig land, when you're writing Zig, your errors get backtraces attached to them. So let's make a quick little example here. So if I have some function main, and in here I call some function that's function A, and he calls function B, right? Let's just kind of make a little call chain here, just so that we have something a little nested, right? And function B calls some function fails, and our function fails, returns error, right? Spaghetti-o. If from main we call function A, and we try this, Zig run source example, we get a nice little backtrace here that shows exactly where the error came from, right? So we see came from fails, came from function B, comes from function A. Which is a little interesting because Zig advertises its errors as kind of being almost just U16s, right? They're just numbers that get returned, and so where does this backtrace information come from is a little bit interesting, but you'll also notice that we don't get that in WebAssembly land, right? Now you might say, well, it's because you're not calling from main, you're calling from some sort of C API, right? So in reality, it's kind of more like this, where you have an exported function, do thing C API, and because this thing is a C function, he can't return an error. So instead what we do is we might do something call function A and get the response value, and if this is a failure, then maybe we want to do something log this thing, right? So we can do std debug print this. Okay, so error name of this guy. Hold on, we need to import the standard library. Okay. So if I run this, we actually want to call that function do thing CAPI, right? So this way, the error doesn't leak out, but it doesn't propagate all the way up. And so now we're kind of back in a similar scenario that we were in the WebAssembly land, where we don't get a stack trace anymore like we did when we just called from main, right? So what do we do about that? Well, there's this built-in function in Zig called error return trace. And if you call this from a context that has an error in it, this will like give you a stack trace. Okay. And you can do something like stood debug print this stack trace, right? Simple. Print this guy. And if we do that, we're so back, right? We see like a backtrace, we goes error, goes to fails, goes to function B. We lose the backtrace of function A. I think that's like an implementation detail. But we at least get like the rest of it. Right, from this context, we called function B fails error O. So we're doing something that's like very analogous to this in our WebAssembly thing. At least we thought we were, right? If we were, well, sorry, this is a little bit. Let's go back to that state that we were in before I fixed the problem, okay? Just give me a sec. So here we go, print the stack trace, right? So this is stack trace is error, return trace, boom. So Zig build probably, and then we go back here, refresh. And what we actually find out is if we try to log this thing, stack trace like this, we put a little goal in there so we can see it, hit a refresh, we see stack trace and just like an empty string. So why is that? Why do we not see the backtrace, which gives us all the useful information about where our error came from? That's like the whole point of the Zig errors is that like I want to see what happened. Otherwise, just like we have to do some of like Rust style, like attach some context to everything on the way up so that we can like get a better picture of what's happening, right? So it turns out, if I understand this correctly, if we look at like the type of this guy, it's a maybe we look at it from the Zig language reference, maybe. Hold on, we go to the Zig language reference. And in here, we look for error return trace. He'll tell us what he returns. He returns a built-in stack trace, right? So if we look at this guy, built-in stack trace, we can actually like see what he's doing here. So he's got like an index, some instruction addresses. Who knows what the hell is going on there? But the interesting part here is when you try to print that thing, he actually is he's like creating a debug information representation of himself. So he's actually like, if you like follow this call chain, he's actually doing something analogous to opening his own executable and parsing the debug info for himself, right? Then what he does is he stores in where were we? In these like instruction addresses. When we like throw an error, he writes down like I threw an error from this location, and he actually like looks at his own debug info and walks the stack back up. I'm pretty sure that's what like, we're seeing happen here. Now there's many instruction addresses because if I understand correctly, we append one for every time we like propagate the error. So I think we can actually prove this. If we go back to our example, and we at the very top of this guy say let's get the stack trace is error return trace. And can we just like very quickly stub this out? And before we do anything, I think that we can like hit a breakpoint on here. So if we run like zig build exe source wasm example, and then what was it? It was line 17. We run this guy. Break at example zig 17. Okay, run. And we set like a watch point on the stack point. So we're like, okay, who is like writing into this field? And I hit continue here. We should see in our backtrace that we, hold on. I don't want to print the stack trace actually. Give me a sec. I think it'll be easier to show this way. GDB example, break example zig line 17. Okay. So watch on stacktrace.index, and we can see who's like modifying this thing. Here we go. I thought last time I tried this, I got to see something more interesting. Maybe we did it from here. Because I swear this is how I tracked this down eventually. Hold on. Hold. GDB B example zig 17. run. Watch. Oh, I'm a dumbass. We have to. I want to watch as the error is getting created, not as we're printing it. So this function call was above. We need this below. Okay, line 16. Line 16. Okay. So example zig 16. Run, and then if we print watch stack trace index and hit continue. So here we see that we are in our failure function in B in A, right? If we continue again and backtrace again, then we see another one in function B, and we hit continue again, and we see another one in function A. What we're basically seeing is we're seeing like somebody in the standard library is appending addresses to this guy. And we can actually see who does this. So if we like look at this function, built-in return error here, return error, here it is. We can actually see what he's doing here. He's like injecting basically like at this index, put the return address here, right? So we know that we're just saying at each time we walk up the return call, every time we like propagate an error, do this. We don't really know how this is getting injected. I was like taking a look at the Zig code gen, and I think I understand. They have like some code in there that basically injects like just call stood built-in return error when there's an error. But it's kind of hard to like trace down a little bit. But we know that this is getting called, and we know that this is how he is inserting information that will be used for backtracing later. Okay, great. Now, back to the original problem. How come in WebAssembly land we don't get one? Well, as far as I can tell, this whole strategy is just fucked. I'm pretty sure. So I think in, like, if you were to think about like the implementation of how you would get the address that you're at right now, right? Maybe on x86, you might do something like, okay, they probably like put the return address on the stack. I know that when I return from this function, I have to know where that information is somewhere, right? So I can probably just like grab that return address and like write it in here, right? In WebAssembly, as far as I can tell, there is no like instruction pointer register that you can like look at like you can in x86. So you can't write like inline assembly to do that. I'm not really convinced that like the WebAssembly function even like I'm not sure that like you can get that information at all, right? I think that really like the browser knows where it's executing, and the browser's in charge of like figuring that stuff out. On top of that, even if we could get the right return address, how would we like convert that into a string that looks like nice for us, right? How could we turn that into like, hold on. How could we turn that into this? Hold on. Right, how can we turn that into this? Because in order to do this, we have to say, okay, so at this address, we have this function, fails. And we know that we are running at example.zig line 7. Like, where's that coming from? Well, like, the executable is opening itself and parsing its own debug info to do this. And again, in WebAssembly land, you can't just open a file, right? The WebAssembly module, even if it has the debug info in there, is not provided to like the code of the WebAssembly module like it is on a regular operating system. So it feels like we're just kind of fucked. It feels like that. But we have a trick. The trick is we're allowed to call out to JavaScript. So let's just quickly convert this into a WebAssembly module and try to instantiate our little example from the context of the web browser. I think this should be okay. So pub export function init. And let's try to make this do the same thing that we were trying to do here, right? So I think that we go into our build here and we add example here. And then I think we should be able to like build this guy. I think debug print won't work here, so we're gonna have to change that into like our, this should be WSR print, like this. And then, what's he complaining about? Unable to unwrap null. Oh, interesting. I don't think this is the behavior I was seeing before, to be honest. This feels surprising. Feels surprising to me. I feel like we used to have the stack trace. Oh, maybe it's here. Yes. Okay, here we go. So let's pop open a little test, test HTML, and can we do something like maybe we'll go to res ingredient HTML. Let's just get fucking copy res ingredient HTML ingredients HTML. Hello res index HTML. Sorry, to test HTML, and then let's configure this guy to call our thing. So it was example WASM, and we were trying to call immediate of page init or something, or maybe it was just init. I can't remember. I guess it'll become very apparent very quickly. So if we go to test HTML, okay, here we go. We see error just like we wanted right here. Error and again, no backtrace. Okay, so we're kind of fucked, right? We're kind of fucked. Except if instead of returning error we type unreachable. Okay, and we do this same thing. Look at this shit. Look at this beautiful backtrace. We have example init, example function A, example function B, example fails. So like, where the fuck is that coming from, right? Well, it turns out that you can embed debug info into the WebAssembly module, and Chrome, when it opens it, will like parse this debug info, right? So he knows all of the stuff, but we don't from within the WebAssembly module. Only Chrome has this info, right? But we can probably like coerce it into giving it to us, right? So what we did was I wrote a little function here that says capture backtrace, and all this guy does is essentially make a new error and print its stack. He saves that stack somewhere, but like really all we need to do is log it right now, right? So if I go back here and I say, return error, but before I return the error, I call capture stack trace is what this is called right now, where I think that this guy needs an index for, he doesn't actually, but for some testing I was doing, he does. So now if I build this, we have this guy printed, without like crashing our thing, and we still return our error. So this is like very close to what we want, right? Except, we don't want to have to log this, right? Because somebody might call this function, they might handle the error later. So what we really want is for this like to be we want to like capture this and store it somewhere and maybe write it down later, right? So those of you who are watching the happy hour stream today, this is like effectively what we did, right? So we kind of converted this to say, instead of doing this, where we print the error, the built-in Zig stack trace here, we can do like a, print captured backtrace, right? And so we can like capture this guy and we can print him. And so if we go back to our JavaScript thing and take out that log, we can like capture it, and now we see our little and then we get our nice little backtrace, right? So far so good. Except we have to fucking call this function, right? If I don't call WSR capture backtrace at every single error site, then like we're boned, right? What am I supposed to do? Well, we kind of worked around this in happy hour by basically just making a function that went like mod error or something, right? And we just called this like mod error like this, right? And put this in here, which it worked. It worked. But it means now that like at every point I'm calling into any function that can fail, I need to know, did I already capture the stack trace, right? Because if I were to do this here and here, right? Let's actually like put the type here, right? So this is like is an any type. He returns himself, and he then does return here, right? If we do this, sorry, like this. Now, like here, if function B calls fails, what we'll actually see is we're going to see the stack trace up to B. We're going to lose the fails in here, if I remember correctly. I mean, that's the way I would expect it to work, right? So here we have no longer fails, right? So we need to make sure that we're only ever calling this function at like the lowest level, right? So this is actually a bug. We shouldn't be doing this. We should be doing this. Okay, so this sucks, right? Blows. Absolutely shit. What would be really nice is if we could like automatically capture this thing every time an error was thrown, right? So like ideally we just kind of do this thing automatically. Here, it would be nice if this was like, Zig, please call WSR capture backtrace, right? This is what we want. And it actually turns out that we can do that. Kind of. Zig doesn't really support this right now, but we can kind of like hack it and it'll work. So remember a minute ago when we were running GDB and we were looking at this like stack trace thing, right? So we had like, what was it? It was like const stack trace is error return trace, and then we were like putting that here, and then we were putting a debug breakpoint here, I think. It was like something like this. Maybe it was like this. We did it here in main, maybe. Yeah, here we go. This is getting close. And then we put a breakpoint here. Okay. Hold on. We're going back. So we built this guy. He's mad because I actually don't know why. Oh, because WSR is still in here. Stood debug back. We need to go back to the debug version. Hold on. We print the stack trace like this. Okay, so GDB, we say run this guy, and we set a breakpoint here. We said watch index here, and continue. So what we're actually seeing here is, again, remember, we can go into the standard library, and when he like returns an error, when he's like making this error thing and he's injecting the stack trace info, that's just a function in the standard library, baby. That's just a standard library function. So what we can do is we can actually just hack it. We can hack that motherfucker. And it turns out that if you do like zig build help, there is a thing in here that lets you override the path to the standard library. Mwah! So all we have to do is go into like the real zig repo and look for stood built-in zig. And in here, we can do something. We can like let ourselves hook in, right? So we can say like if, has decal root return error hook or something, right? So I think it's actually like this. If this function exists in root, call that motherfucker. Okay? Just call it. We don't have to think much more than that. Just fucking call that bad boy. And then I think I have to build zig here for it to get where I want to go. And then in here, when I call zig build, I can just go like zig libdir is equal to zig out lib. Maybe it's like this. Zig out lib. I thought that was it. Oh, maybe it's zig out lib zig. Yeah, there we go. Okay, so now we have like our modded standard library function, right? Who calls our hook. So all we should have to do, let's just like test to ourselves that does what I want. So if I go in here, I can go like pub function, what was it? Return error hook, I think is what we called it. Can we just like a stood debug print in here for a second? Hi, I'm in my hook. And we're hoping that through this error return, this function will get called. So let's see. Sorry. We were calling build exe before. We might have to get a little fancy. Zig libdir? Looks like we're chilling. So build exe on Zigo, our source WASM example. Oh, we forgot the very crucial, I don't have any arguments here. So if we call this now, oops, let's take out that breakpoint. Hold on, he's thinking. Right, look at this shit. We got our shit called. Now he's spamming like an absolute motherfucker, right? But we do have like proof that we are running something. Now, I suspect that there's, some shit where we've got like some recursive bullshit happening because probably hi, I'm in my hook has like some like possible errors or something that are going on in there that he's like handling. So there's probably something fucked up there. But if we go back to like the WASM version of this, and we were to just write like WSR zig here, and we did like WSR capture backtrace, now we should be in a pretty fucking good spot, right? So let's go back to this init function. Maybe comment out main and zig build with this guy. So give him a sec. He's got to recompile his build script. Let him think a little bit. He's got to figure himself out. Got to rebuild all of our WebAssembly modules, of course. And he's mad because error return trace, you know, we can't use this thing anymore. Fine. Give him a sec. Okay. So what we're hoping is that this will capture the backtrace when we return error here, and then we can print it, right? Refresh. We are in the error return hook, capture backtrace, really good for us, except we're actually on the top level one, right? Function A instead of function B or fails, right? And that's because of what we saw before, where this like return error is triggered at like each level of the call stack. So we just have to make sure that we're only doing it on the first level, which we could do by being like, okay, give me this stack trace, you know, give me this bad boy. And we have the index field here. So if we can say, if we're on the lowest level of, you know, of this like return thing, only capture the lowest level. And look at this shit. Look at this wonderful, beautiful backtrace. Look at this. We have like example init, example function A, example function B, fails. Mwah! Mwah! It's sick, man. It's sick. And so if we actually go back to our like original test case here, ingredients, am I in the wrong folder? Ingredients.zig. In here, this original thing was triggered by this return error If we just do the same thing here, where we have this on return, we called it return error hook, I think it was called. We should get a nice backtrace here as well from this return error without any extra work. Hold on. Give him a sec, he's got to think. But I think if we go back to here, unlucky, but maybe, hold on. First of all, is this guy getting called? Hi. Did we do something wrong here? We might have. Okay, no, okay, so this is fine. It's probably that we weren't, so here we are capturing the backtrace. So can we say, what is it? Print captured backtrace. Let's just double check that this is triggering one time. He should be triggering one time, I think. We'll see. Oh, interesting. Maybe this isn't working the way I thought it would. Hold on. Maybe we found a problem. The fuck? Oh. I accidentally renamed the function. Last time I did this, I used a different function name, so I was confused. Okay, cool. So we'll go back to, okay, so here we should be like captured backtrace. Hold on. Give him a sec. Yeah, okay, so this is working. So then why is it not printing? Oh, because we commented this out like a dumbass. Okay, so we should be able to capture the backtrace and see that this came from, in the ingredient parser, we should see an error, right? So here we look at parse here. A little unlucky here on the source map, but I think we at least have the right function here. And we know that we're, yeah, interesting. Interesting. And I guess we know also the, uh, yeah, that's not as good as I was hoping, honestly, because I thought last time I tried this, I thought that it gave me like the exact thing, but maybe not. Maybe we were a little less lucky, right? So at the very least, let me try putting it somewhere else, right? Let's try putting it in next as int. We'll say if true, return error. Uh-oh. Let's just see. Because I thought that in the happy path, we got almost like a perfect backtrace. Yeah, here. JSON zig 154. If true, return error. Oh, look at that. Look at that. Mwah! Oh, it feels good. So we've actually just like solved a pretty major problem for ourselves, right? That's kind of crazy. Where the fuck is the console? Hello? Can I get the console back, sir? Here. Right? So we went from not being able to basically only seeing like one line unexpected token to a full backtrace that is automatically generated by calling out to JavaScript from WASM anytime an error is returned in Zig. That's fucking sick. That is so sick. Like, we're so fucking back. Yeah, so I just thought that was kind of cool, kind of fun. I don't know if this is like a reasonable thing to be doing, right? Let's just be clear. I don't know if Zig compiler devs will look at me and be like, bro, what are you doing? But if we could, you know, at the very least, it's like solving a problem, and it seems to be working for me for now. So I'm gonna probably keep this mod in at the very least, because otherwise, like working with WASM and Zig, I think would be almost a no-go for me. If like we have, because in order to like find this error the normal way, you have to like almost like bisect your whole code base and like replace every instance of that error with unreachable or something. And even then, it doesn't really work because maybe sometimes you're supposed to error out and you're like trying to catch that error in other places. It's like a mess, right? So this backtrace is like incredibly important to me, and we fucking got it. How fucking sick is that, guys? How fucking cool is that? So yeah. Anyways, I just thought that was kind of neat. Thanks for watching. Peace out. Catch you later. Bye.